Hello students, today I will explain about electric potential. So last time you have learned about what is current electricity. It means the rate of flow of charge through a conductor per unit time. And you have learned that the current actually flow from higher potential to lower potential. Okay, suppose this is a conductor, and you know that if you apply a battery, when we connect a battery to the conductor, then current flow through the conductor, and the direction of the current is always from higher potential to the lower potential. Okay, so whenever we use the term that potential, what does electric potential mean? So now I am going to explain about the electric potential. Okay, so what is this? This is a conductor and this is a battery, and we have connected the battery to the conductor, and we know that current flow to the conductor, and the direction of the current is always from positive to the negative. that means the positive terminal is considered as at higher potential, this is considered as at high potential, and the negative is considered as low potential. And current always flow from where? Higher potential to lower potential. Okay, as you know that in case of water also, water always flow from where? Higher potential to lower potential. Suppose here is an example given here. Here there is a two vessel is there. Here vessel A and this is vessel B. In the vessel B the amount of water is more, but in the vessel A the water amount is less. But when we open this clock, then what happen? The current or the water flow from the vessel A to the vessel B. And because why? Because the water in the vessel A is at higher potential. Maybe the water in the vessel A is less amount, but this water is at higher potential. Okay, so from higher potential to the lower potential, the water flow. Similarly also the electric current that flow from higher potential to the lower potential. Okay, so electric potential is a condition which determines the direction of the flow of the charge. Suppose here one example I can show. You know that positive, negative and zero potential. So what is positive potential, what is negative, and what is zero potential? Suppose you can see here, this is a conductor, and we have support this conductor, this spherical conductor with a insulating body, and we have connected this conductor with the earth, and the earth is always at zero potential. So this body A, this body let assume that these have what? Positive charge. So this positive charge is always considered as a higher potential, and the earth has what? Zero potential. Therefore the body has higher potential comparing to the earth. So whenever we connect the spherical body with the earth, then the current flow from higher potential to the lower potential. Okay, so we can see here the direction. This direction represents the direction of the current flow, that is from higher potential to lower potential. And in this figure is also another spherical conductor, and this conductor has what? Negative charge. When we connect with the earth, and this negative means what? Less potential. So the earth has zero potential. So negative is less than your zero. So current will be flow from where? Earth to the conductor. Why? Because the earth have zero potential, and zero potential is greater than your negative potential. Therefore earth is at higher potential and the conductor has at lower potential. Therefore current will flow from your earth to the conductor. Okay, now I am going to explain how is the electric potential is created. So in this figure I told you that let this conductor end is A and this end is B, and this conductor end is at higher potential and the B is at lower potential. Why? Because this end of the conductor is connected to the positive terminal of the battery, and this is and B is connected to the negative terminal, and hence A is at higher potential and B is at lower potential. Okay, now question is that how the potential is created in the conductor. You know that in the absence of the battery there will be no potential in the conductor, but when we connect the battery to the conductor, then only potential develop in the conductor. Because why? Whenever the current flow from higher potential to lower potential, there has some work done. Okay, so this work done means there is some loss of energy. Whenever we do some work, then there will be obviously there will be obviously some loss of energy, and this loss of energy will be gained from where? This is comes from the battery. Okay, so the battery means the cell lost some energy and maintain a potential between the conductor A and B, and therefore current able to flow from A to B. Okay, again I explain that whenever we connect the battery to the conductor, then current flow from through the conductor in this cycle, in this direction, that is means from higher to lower potential. Now the question is why? Because a potential develop means whenever we connect the battery, current flow from higher potential to lower potential. Okay, so whenever the charge flow from higher potential to lower potential, then there is some work done, and this work done means there is some loss of energy, and this loss of energy is gained from the cell. Okay, so this cell loss energy means they spend energy and maintain a current in the circuit. Therefore the energy spent is called electric potential. Okay, so the measure of the energy spent is called what? Electric potential. Now the definition of electric potential is the amount of work done, that is energy spent in moving a unit positive charge from infinity to a point in an electric field is called electric potential at that point. Okay, so in this case I again repeat, you see here they have talking about a from infinity to a point in electric field. So this topic we have not discussed. I am going to explain it. Let this is a point charge, is a Q charge. Okay, so you know this charge have somewhat electric field around it, and let P is a point in the electric field. Okay, so if you are taking a charge Q naught from infinity, what is Q naught here? Is a unit positive charge. So unit positive means 1 coulomb plus 1 coulomb. From infinity we are taking this charge from infinity to the point P. So obviously there will be some work done in carrying the charge from infinity to the point P, and the amount of work done in carrying this unit positive charge from infinity to that point is called what? Potential at the point P. Okay, so what is electric potential? Electric potential at P point is the electric potential at P point is represented by V, and it is the amount of work done in carrying the unit positive charge from infinity to the point P, and this point P is where? It is inside the electric field of plus Q charge. Okay, now I am going to tell you that the unit of electric potential is what? Volt. It is denoted by letter V. Okay. Okay, the next topic is the potential difference. What is potential difference? Let's see the definition of it. The amount of work done, energy spent in moving a unit positive charge from one point to another in an electric field is called potential difference. So what is potential difference means? The amount of work done in carrying a unit positive charge from one point to another in an electric field. Okay, let's see, this is a conductor here, and I have connected this conductor with the battery. So what will happen? That current will flow in the circuit. Okay, so what is AB here? AB is a conductor. Now why current flowing in the direction of A to B? Because A potential is at higher potential and B is at lower potential. Okay, so that means I can say there is some potential difference between the terminal A and B. Okay, so what is the potential difference by the definition? It is the amount of work done in carrying a unit positive charge from one point to another in an electric field. You see here, whenever I connect a battery, then if one terminal is positive, another is negative, then you know that electric field is developed inside the conductor. Okay, and obviously the direction of electric field will be in the direction of what? Positive to negative. So what? These are the electric field. And so in the electric field, if you are taking a unit positive charge, that means 1 coulomb plus 1 coulomb from one point to the another, there will be obviously some work done. Okay, so I can repeat, in the conductor AB, an electric field is developed. Why? Because we have connected a battery, and hence in the electric field of the conductor, we are taking a positive charge, unit positive charge, that means from one terminal of the conductor A to another terminal B. Okay, so while carrying this charge from one point to the other, there will be some work done, and the amount of work done, this is the nothing, it is the potential difference between the 2 points. Okay, suppose VA minus VB. So what is VA minus VB means? It is the potential difference between the two terminal A and B, and that will be equal to the amount of work done in carrying the charge, okay, plus 1 coulomb, and this is called the potential difference. So what is potential difference? Potential difference is equal to the amount of work done in carrying the charge 1 coulomb from one point to the another. Sometimes the potential difference is also simply written as V. What is V for? V means the potential difference between A and B. Okay, so VA minus VB is equal to the potential difference between the terminal. Now, suppose I like to say that I have not just moved plus 1 coulomb, that means unit positive charge from A to B. Let plus Q amount of charge, let Q units of charge is moved from A to B. Okay, and W is the W is the amount of work done. Okay, I can repeat, Q units of charge is moved from A to B, and W is the amount of work done in carrying the charge Q from A to B. Okay, and what is the potential difference between A and B? I told you that let V, that V means VA minus VB. VA minus VB is the potential difference. Okay, therefore, so I can write here work done is equal to what? Therefore, the work done for 1 coulomb of charge, that means for 1 unit of charge will be what? Q by V. Okay, why? Because W is the amount of work done for the Q amount of charge. Now, if I say that for 1 coulomb of charge, that means W by V. Okay, so there are some mistakes, so I can repeat. So W is the what? W is the amount of work done for Q amount of charge. Now I am talking about that work done for 1 unit of charge, so obviously it will be W by Q. Okay, it is not Q by V, it will be W by Q. Why? Because W is the amount of work done for Q amount of charge. So if I take the ratio, the W by Q, that will give your for 1 coulomb of charge. And by definition, the amount of work done for 1 plus 1 coulomb, that means it is the potential at that point now. So it is the potential difference. So it is potential difference, or simply we can say the potential at that point for 1 coulomb of charge, we say it is a potential. So it is equal to W by Q. So V equal to W by Q. Therefore, by definition, potential difference is equal to work done per unit charge moved. Okay. Some important terms with this potential difference I would like to mention you here. You can see potential difference is a scalar quantity. So you know that there is a two quantity, physical quantity, one is scalar, another is vector. Potential difference is a scalar quantity, and potential difference is measured by an instrument called voltmeter. Okay, and this is the example, this is the figure of the voltmeter. Okay, so whatever bit of volt, that will show the reading by the scale. So voltmeter is always connected in parallel across the 2 points in an electric circuit where the potential difference is to be measured. Suppose here is a conductor, current flowing from A to B, and this is a conductor. Okay, so in this conductor, if you want to measure the potential drop in the conductor, then you have to connect the voltmeter in parallel to the conductor. So voltmeter is always connected in parallel for the measurement. Number 4, the voltmeter is a high resistance instrument and draws negligible amount of current from the electric circuit. So whenever you connect the voltmeter with the circuit, there will be no change in the current in the conductor. Because why? Because this voltmeter draws a very negligible amount of current from the circuit, and hence there is no resistance in the current through the conductor. The voltmeter also has a high resistance. Okay, voltmeter has a high resistance, hence it draws a very negligible current. Okay, thank you.